Good day, learners. You are welcome back to our chemistry class today. In today's chemistry class, we are going to continue on our gas laws. Specifically, we are going to look at the law of combining volumes of gases. From our previous classes, we are able to look at Boyle's law, Charles' law, in which Boyle's law and Charles' law, both of them are talking about the behavior of gases, which are physical. That is, physical behavior of gases. But in today's class, we are going to look at the chemical behavior of gases. Then we'll be diving into two laws, which are Gay-Lussac's law and Avogadro's law. The first one we talked about is Gay-Lussac's law. Before we dive into this properly, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. If you are a usual member, thank you very much. And don't forget to share, like this program. The first law is Gay-Lussac's law. Gay-Lussac's law discusses a mixture of gases that react together, that is, chemically. Gay-Lussac's law states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volumes of the gaseous product, provided that they are under the same conditions of temperature and pressure. What does this mean is that when gases are reacting, they react with simple numbers. And to give our product, which is going to give a simple numbers. That is, gases doesn't react using a larger numbers, like saying 35 mole of hydrogen reacting with 80 moles of oxygen to give 115 moles of water. That doesn't happen to gases. Instead, simple volumes will be reacting together. So Gay-Lussac's law is talking about volumes. Let's see for an example. Hydrogen reacting with oxygen to give water. Now, hydrogen gas and oxygen gas to give gaseous water. So, if I put 2 here, then I put 2 here. Look at this. This is 2 volumes. 2 volumes reacting with 1 volume to give 2 volumes. Now, you can see that these are simple ratios. 2:1, ratio 2. So this is what Gay-Lussac's law is discussing. Gases are reacting in simple ratios to give a product which are also in simple ratios. Let's say, for instance, again, hydrogen reacting with nitrogen to give ammonia gas. Hydrogen gas reacting with nitrogen gas to give ammonia gas. We have 2 moles of hydrogen here. We have 3 here. Let me put 3 here. And let me put 2 here. So I think this is balanced. So 3 volumes of hydrogen combining with 1 volume of nitrogen to give 2 volumes of ammonia. Don't forget the volume here. If I want to put it in, it's going to be 3 centimeter cube, reacting with 1 centimeter cube to give 2 centimeter cube. So 3:1, ratio 2. These are simple ratios. Likewise here, 2:1 and ratio 2. These are simple ratios. So this is what Gay-Lussac is talking about. These gases are reacting, but they are reacting in a simple ratio. The second principle that discusses the reaction of gases is Avogadro's principle. A scientist called Avogadro buttressed on Gay-Lussac's law after Gay-Lussac's death. That is, he also studied the reaction of gases and then made up his hypothesis that gaseous are also reacting. His hypothesis later became what we call a principle or a law. In this case, Avogadro's principle or law states that equal volumes of all gases under the same conditions of temperature and pressure contain the same number of molecules. When gases are reacting under the same condition and pressure, they are going to contain the same number of molecules. You can see that the similarity here. Gay-Lussac is talking about volume, while Avogadro is talking about number of molecules. Let's say, for instance, hydrogen gas is reacting with oxygen gas to give water molecules. Now, in this case, we say 2 moles of hydrogen reacting with this 1 mole of oxygen to give 2 moles of water. If you consider it to be 2 volumes of hydrogen to 1 volume of oxygen to give 2 volumes of water, this is Gay-Lussac. This is the Gay-Lussac. But when we are considering the number of molecules, 2 moles of hydrogen reacting with 1 mole of oxygen to give 2 moles of water, this is what we call Avogadro's. So Avogadro's principle is talking about number of molecules, while Gay-Lussac is talking about number of volume. Likewise, 3 moles of nitrogen is combining with 1 mole of hydrogen to give 2 moles of ammonia gas. If we are considering the volume, that is Gay-Lussac, but we're talking about the number of molecules, that is Avogadro's. 3 moles of this combining with 1 mole of this to give 2 moles of ammonia gas. So in Avogadro's principle, volume of a gas is directly proportional to the number of molecules. Meaning that the higher the volume of a gas, the higher the number of molecules of that gas. The lower the volume of a gas, the lower the volume of number of molecules of this gas. So Gay-Lussac and Avogadro's principle, they are talking about the same thing. Why Gay-Lussac is talking about the volume of gases, while Avogadro is talking about the number of molecules under the same condition of temperature and pressure. So these gases react. If you are a new member on this channel and you have not subscribed to my channel, kindly subscribe to this channel and click the notification bell for my subsequent contents. In our next class, we are going to be dealing with the calculations under Gay-Lussac and Avogadro's law. Don't forget to share this lesson and click the like for other learners for them to benefit. I remain your tutor in mathematics and chemistry, Latif Ismaila Akambi. Thank you very much.